Okay, we're back for a thrilling part 2 here. Okay, so medical math. This equation, we can get a lot of money out of this equation. Okay, the amount we're going to give is equal to what we desire over what we have times the vehicle it comes in. Okay, so amount to give is in milliliters. The desired is either equal to milligrams per kilogram times the amount of kilograms they are, or the order. And then the catch here is this one was tricky, I feel like, when I taught pharm. Vehicle refers to the volume of drug, okay, and have equals the mass of drug. So a volume is going to be a milliliter, okay, and a mass is going to be a weight. It doesn't have to be these units, it just has to be, one of them is going to be a volume, so like a milliliters, liters, etc. And mass is going to be some kind of weight unit. So let's move forward on adrenal crisis and look at hydrocortisone. Okay, so it must be provided to us. We give 2 milligrams per kilogram to a max of 100, and we're going to round to 10 milligrams. Okay. Since it's provided to us, I thought it would be fun to give us 3 different concentrations. So we got 100 milligrams per milliliter, 100 milligrams per 10 milliliters, and 500 milligrams per 10 milliliters. So this first question here, we got 48 kilogram patient, and we're going to give drug A. So let's figure out our desired. Okay, our desired. So D is equal to, we know that desired is equal to milligrams per kilogram times kilograms. So we're going to go 2 milligrams per kilogram times 48 kilograms. Okay, get this lovely ability to cross out things when we're dividing them. And that's going to be D equals 96 milligrams. Okay, so now we can set this into our equation. Okay, amount. Okay, let's just call amount. Let's just call amount X. So X milligrams. No, sorry, X milliliters is equal to desired. We have 96 milligrams, and in our vehicle, it's actually probably simpler to think of what have first, because we have 100 milligrams. We have 100 milligrams in a vehicle of 1 milliliter. Okay, so this is where it gets a little trippy. Get rid of this thing. We don't need to multiply stuff by 1 milliliter. That's annoying. Get rid of that. But if we get rid of that, what's the problem here? We'll end up unitless, okay, because we'll cancel these things out and we'll end up unitless. So if we don't just rush away to get rid of things, this is where we get our milliliters from. So we can cancel out milligrams, and now we're going to get 96 divided by 100, and that's going to equal 0.96 milliliters, which makes sense if we just logic this out. 100 milligrams in a milliliter, so we're going to give just under a milliliter. Now some of you, if you really hate math and you're still really smart, will notice right away that we're rounding to 10 milligrams. And as soon as you saw 96 milligrams, you were probably like, give all of it. Nice. Okay, let's do another one here. So we got 21 kilogram patient with B, which is going to be 100 milligrams in 10 milliliters. Nothing changes on our dosage. Our desired is going to equal 2 milligrams per kilogram times a 21 kilogram patient. Okay, so this is going to equal 42 kilograms. 42 milligrams. Cancel out your kilograms to prove that. And now let's learn from last time, and let's just simplify that down to 40 milligrams right away, because we know we can round to 10 milligrams for our dosage. So now we can say our amount in milliliters is going to equal 40 milligrams, and that's going to be over, this time we're going to use drug B, so 100 milligrams. However, this one's a lot more diluted. Okay, so it's going to be times 10 milliliters. So in this case, we're going to have milligrams cancel out, and we're going to get 0.4 times 10 milliliters. Okay, so that's going to equal 4 milliliters. Makes sense? We're going to give 40 milligrams, and it's going to be 4 milliliters. And our last one, let's just grab this guy here. We're going to use C. So C is 500 milligrams in 10 milliliters. Okay, we got 2 milligrams per kilogram. Those will cancel out. So we're going to get 60 milligrams. X milliliters is going to equal 60 milligrams. And this time we're going to be, holy, I'm sorry, it's sliding all over the place here. 500 milligrams times 10 milliliters. Okay, so just from the logic of this, we just did a very similar equation, and it was 4 milliliters. However, this time we're much more concentrated, so it's unlikely to be as much as that. And I think there's a couple ways you can go at this. You can go, 60 divided by 500. I don't like that. So you could use a calculator and find out that it's 0.12. Okay. Or you could multiply the 10 milliliters in first, and that would give you 600 milligrams over 500 milligrams, which goes in one time and a fifth time. Okay. One time would leave us with 100 milligrams left over. And what do you know about 500 is that dividing it by a fifth, that's 5 blocks of 100. So 5 blocks of something is 0.2. So there's a little bit of logic there as well. So you're going to get 0.2 left over. So you have that option of 60 divided by 500 in a calculator equals 1.2. Or you could multiply the 10 in to the numerator, get 600 over 500. Realize that's going to go in 1 and a bit times. And then you could do some cognitive tricks to help yourself figure out how to figure out how much that bit is. Okay. So X milliliters would equal 1.2 times 10. Sorry, I'm doing this for 2 different ways. If you've already multiplied your 10 in, then you're done. You don't have a 10 left over anymore. It's gone. So in this case, when you do it this way, it's 1.2 milliliters. Okay. But if you do this calculation, this is my problem here, I'm so sorry, that's 0.12. Okay. Obviously 500 does not go into 60 one time. And if you're a little confused, that makes sense that you just got a little lost. And if you immediately sussed out that error, that's really good. So in this case, this is 0.12. And then that's going to be times the 10 milliliters if we didn't bring the 10 milliliters into the 60. So in this case, we have to solve for this, which would equal 1.2 milliliters. Okay. All right, so that's some PCP math there to use it. Now, if we jump back to working with ACPs, a little bit of learning again here for you. Probably a good time to just pause, take a break, have a math, mental health decompression moment, and then you can come back and we'll do some more math. Okay. So when we talk about Midazolam, the big thing to realize is that it's given for 2 different directives. It's given for combative patients and seizure patients. And when we give it for combative patients, we give up to 0.1 milligrams. But when we give it for seizure patients, we just give 0.1 milligrams. There isn't this up to component. And then to make it even more confusing, we actually give 0.2 milligrams if we don't give a potent route. So if we don't give it IV for a seizure, we're going to give 0.2 milligrams. So we've just got a lot of dosages. So just make sure that you kind of maybe encourage your ACP to pump the brakes and make sure they know what dosage range they're working with. So up to combative, let's say we've got a 50 kilogram patient and they're being violent. Okay. Midazolam comes in 5 milligrams per milliliter, which is super nice. So let's figure out our dose. So 50 kilograms times 0.1 milligram per kilogram. Okay, up to. So anything, I could give a little less than this, basically, and be allowed. But in my instances, I'm personally just going to give that. That standardizes it with this seizure drug dosage and reduces error for me. So this is going to be equal to, I need 10 of these to make 1 milligram. So if I have 50 of them, perfect, I have 5 milligrams. So the max dose is actually 5 milligrams as well. So since this is the max dose, we're done here. Not only is this the amount it comes in because it's only in 1 milliliter, but we can make the rule here that for greater than 50 kilograms, so that's only like 110 pounds. If above that, they're just going to get the max, which is just 0.5. All right. Now let's look at a seizure patient. Same idea. It's exact same idea. Let's just say that they're 30 kilograms. Okay, so 30 kilograms times 0.01 milligram per kilogram. My kilograms cancel out. I'm going to give 3 milligrams. Okay. And now let's stick that into our equation. So our volume in milliliters is going to be equal 3 milligrams. We have 5 milligrams as our midazolam, and it's going to be in 1 milliliter. Okay, so we can cancel out our milligrams, and that's going to be 0.6. Okay, denominator is greater than the numerator, so it's less than 1. Okay, so that makes sense. This milliliters comes down here. So the idea here is that if I just do that calculation and then I find out, no, I don't have an IV, let's give it IM, well, it's just double, right? It's just double. So I can just take this number, multiply it by 2, and that means it's 1.2 milliliters IM, IN, or buccal. All right. Another option we have for combative patients is ketamine. And ketamine just has a different amount of dose per kilogram, which is kind of unique for it, for the age range of 65. So if we have a 65-year-old patient or greater, they get a little bit less ketamine and therefore a little bit less of a max. And if they're less than 65, they get a little more and they get a max. Okay. And what we can see here, if you're quick, you'll notice that the max, if we try to get into this idea of like what is the maximum weight to get the maximum dose, then what you'll see here is that for ketamine, whether it's 3 or 5, the max weight to get the max dose is 100 kilograms. And ketamine's pretty potent. Okay, it comes 500 milligrams in 10 milliliters. So we have a 30-year-old patient, 220 pounds. Okay, so remember we got to divide this by 2.2, which is going to equal 100 kilograms. So for anybody 220 pounds and up, they're going to get 5 milligrams per kilogram times 100 kilograms. Kilograms cancels out. It's going to equal 500 milligrams. Okay, that comes in 500 milligrams in 10 milliliters. These whole terms cancel out. Okay, so now I get 10 milliliters. What do you know about 10 milliliters? TXA, we're going to have to give 2 5 milliliter injections. Okay. Another option here, we have a 70-year-old, so we're going to be doing 3 milligrams per kilogram, and they're 45 kilograms. Okay, so that's going to equal 135 milligrams of drug. We're still going to be using the same vial of ketamine. Okay. You will make all kinds of mess for yourself if you mess this calculation up. So this is going to be a calculator question. So that's going to equal 0.27 times 10 milliliters, which equals 2.7 milliliters. So we can get that in one syringe now. All right. Now here, if you're noticing, like if you weren't uncomfortable by how much comes in here off of these combative questions, strap yourself in for when we do it for pain, because when we give this person IV medication, IV ketamine for pain, we need to give them 0.25 milligrams per kilogram to a max of 20. So let's say we have this 30-year-old patient and they are going to get 0.25. That's a scary sounding number, but that just means a quarter, right? So I feel like intuitively you'll snap a quarter pretty quick. Milligrams per kilogram, and they're going to be an 80 kilogram patient. Okay, well, I can see the relationship right there. That is a quarter. Okay, 20, 40, 60, 80. Okay, so that's 4 blocks of 20. So that's going to equal 20 milligrams. But when in doubt or when knocking somebody out, please use a calculator. Oh, I like that. That's a good one. Okay, so we're going to give this person 20 milligrams of ketamine, and it comes in 500 milligrams. and it comes in a vehicle of 10 milliliters. Okay. So we'll follow my little mantra of when in doubt or knocking somebody out, to use a calculator. So that would end up being 0.04 milligrams cancel out times 10 milliliters equals 0.4 milliliters. If you looked at this and were like, I don't need a calculator for that, that's 4 milliliters, you are going to have sent this person on a ride. So that is 0.4 milliliters. That is a 1 milliliter syringe. Okay, that is a small dosage thing. So the max dose of ketamine is 0.4 milliliters for pain, which means if you're using ketamine for pain, give the ACP a 1 milliliter syringe. They can probably are doing this all themselves as a control freak, but if you see anybody getting 2 injection needles out for ketamine for pain, we have a big problem here. The final drug you'll see is dopamine. It comes in a bag. This bag is actually 1,600 micrograms per milliliter, which is what we used to call double strength. But I'm going to use 800 micrograms per milliliter, which is a single strength. And this is an infusion. We're going to run this over a certain amount of time. So we need to bring back this guy, okay, where we have the drop factor brought in here. So here's what's going on here. The dosage is 5 micrograms per kilogram per minute. Okay. And we have a 80 kilogram patient. So let's calculate that first. 5 times 80, so that's going to be 400. Okay, kilograms are going to cancel out. 400 micrograms per min is what we'd be left with. So the dosage here will be 400 micrograms per min times a drip factor, always going to be a micro or a buretrol. So you're going to have to know that one. Okay, so that's 60 drops per milliliter. And that's over the concentration of our dopamine, which is 800 micrograms per milliliter. Now you have the funnest part of math. You get to cancel things out. And we get 1 over minutes. Here's how this will work. Because you can see our minutes and drops aren't really working out here. So what's happening here now is that we have 400 times 1 over minutes, okay, times 60 drops. And then we have 800 left down here as well. So that's going to simplify to 400 times 1 times 60 will be 24,000 drops over 800 min. Okay, I know these units don't make sense, but that's just how you do dimensional analysis, or how you remove units. So if you simplify this equation, if you were to give somebody 24,000 drops over 800 minutes, you're going to be there a while. But if you reduce this and simplify this equation out, it ends up being 30 drops per 1 minute, which you're probably more comfortable seeing as 30 drops per min. Okay. So now if you have 60 drops or 60 min in a second, and I want to figure out how many drops per second, okay, 60, yeah, there's your problem, derp. There's a lot of really easy spots to mess math up. 60 seconds in 1 minute, okay, times 30 drops. I don't know how I do that. What I'm trying to solve here, why I'm going slow, is I'm trying to figure out how many drops this is a second, which means I do need to get drops on the bottom, because I can't cancel these two out. I can't cancel minutes out on either side. So I know I'm not messing with this thing on the right. Okay, this is my answer. This is good. I like this. But I need to get to drops per second. Okay, so that means I need a per second and I need something where I could cancel minutes out. Okay, so 1 minute has 60 seconds. Okay, it's really important that these are not interchangeable because one of these answers is going to give us 0.5 and the other one is going to give us like the complete opposite. One of us is going to give them 2. Okay, so we want half a drop a second to get 30 drops in a minute. We don't want 2 drops per second because that's 120 drops in a minute. So these are just really fine calculations and stuff, and they're very easy and very routine. It's just really important that you practice them and you see where you can make mistakes. Okay, I'm never going to do this perfect every time, but you just do a lot of equations, and it starts off like really uncomfortable when people do this whole crossing out thing, but it is honestly, it is the solution to getting good at math, is simplifying your equations out and being able to just see like this little moment here. If you rewatch this video where I said I want to figure out drops per second, I know I'm not going to mess with my answer. How do I get my answer into drops per second? Well, I just put it there. And I say, okay, well, I'm keeping drops and I need seconds on the bottom. So now I need to get rid of minutes. And then this little problem, this term just writes itself. Okay. So that's an exposure to some medical math. Being able to calculate these is obviously outside of your scope or what you need to prioritize. I hope you can take away just a little bit of exposure to the directives. But the reality in this conversation and video is that math is math. And if you can do these questions, then you can do hydrocortisone. Okay, it's all really the same stuff, the same formula that got us all through stuff. And you can make up some of your own questions as well. Hopefully that's helpful. Enjoy. I will see you Wednesday.